Hi everyone. Today I'm going to discuss one of the most controversial proof in the history of maths, and which is the summation of natural numbers up to infinity, and it comes out to be minus 1 by 12. This proof was given by Ramanujan, and let's first see how it's proved. So I'll first take this series up to infinity, and this can be written as, and we get s0 equal to half. Second, let's take this series. I'll just shift this series by 1 and then add both of these. And we know that this sums to S0, which is 1 by 2. S1 is equal to 1 by 4. Now let's take the main series and take S1. Now we can write S1 as 1 plus, and I'll subtract 2 times, and this is actually S minus this is, if we take a 2 common from it, it will become 4S, from which we get minus 3S is equal to S1, which is equal to 1 by 4, and hence S is equal to minus 1 by 12. Okay, so this is extremely counterintuitive that we are taking a lot of positive integers and we are getting a sum that's negative. First of all, it's negative. Second, it's a fraction. So how is this possible? Let's see another way of calculating 1 plus 2 plus 3. We know that any integer can be written as 3p, 3p minus 1, and 3p plus 1. And sum of it would be 9p. So 2 is 3p minus 1, 3 is 3p, and 4 is 3p plus 1, where p equal to 1. Similarly, here p will be 2, and so on. So what we'll get is 1 plus 9 plus 18 plus 27, and so on, which implies it can be written as 1 plus 9 times 1 plus 2 plus 3 plus, and so on. And again, we get s is equal to 1 plus 9s minus 8s equal to 1, which implies s is equal to minus 1 by 8. So which is correct? This one or this one? Now let's take this series. In higher calculus, when we study convergence and divergence of series, we prove that this series is a divergent, which means when number of terms tends to infinity, the sum tends to infinity. Now, when I was going through the Taylor series of ln 1 plus x, I saw that it's x minus x square by 2 plus x cube by 3, and so on. Now, if we put x equal to 1, which is absolutely in the domain, since the domain is x is less than equal to 1, what we get is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. Now I thought we can find this series using this, as we did earlier with the natural number sum, that is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 minus 2 times 1 by 2 plus 1 by 4 plus 1 by 5, and so on. Sorry, plus 1 by 6, and so on. Now this is equal to s, and this is equal to minus 2 times s by 2. So we get s minus s, which is equal to 0. So in conclusion, we are proving that ln2 equal to 0, which is absolutely rubbish. So what is the mistake that we are making here? Now, if you look carefully into this, what you are going to get is that this is an divergent series and s tends to infinity. Okay. When this is large, s tends to infinity. And this is again a divergent series. When it's large, s tends to infinity. Now the mistake that we are making is we are subtracting infinity from infinity. Now, if we have studied the fundamental of calculus, then infinity minus infinity is an indeterminate. And we cannot directly say that infinity minus infinity is 0. So this is the mistake that we are making. And to compute limits such as infinity minus infinity, we need to find some other way of deriving this. So what we can actually write is and we need to find some other way to obtain this relation that ln2 is equal to this. Now, I don't think we can proceed any further with this, but what we can figure out is that infinity minus infinity is an indeterminate and we cannot use the laws of algebra breaking the boundaries of calculus. So here, in this step, when we perform this s minus 9s, is actually a infinity minus infinity indeterminate and we cannot write this thing. This is wrong. Again, when we go up, we are making the same mistake in this step. This is again an infinity minus infinity indeterminate and we cannot write this. Also, when we write s0 equal to half, then the mistake that we are making is that this is a 1 plus 1 plus 1 plus 1 till infinity minus 1 plus 1 plus 1 plus 1. This is again an infinity minus infinity indeterminate. So we cannot write this. Now there might be many times when you encounter similar kind of proofs, and now you can have an idea what is the most probable mistake that we are making. If this is correct, then ln2 should be equal to 0, which is absolutely not correct. And thank you so much for watching. Have a nice day and please subscribe if you like this video.